All right, so the next time we're going to go ahead and look at these, we're going to look at the half-angle identities. Now, the half-angle identities are interesting because we have this plus-minus piece with these. Now, this plus-minus doesn't mean that it's plus or minus inside the function. What that plus or minus means is you choose whether it's positive or negative based upon what quadrant this is. Is we positive or negative is determined by the quadrant. All right, so everything we're going to be doing in this video is going to be related to our given statement. My given statement here is that the cosine of theta is equal to -3/5. So I'm going to define this theta as this theta has to be between pi and 3π/2. So let's go ahead and take a look at where that ends up. Right now, what I have is I know that my cosine, again, my cosine is always equal to the adjacent over the hypotenuse. The adjacent is my x value, so my x value is -3. My hypotenuse down here is 5. This is a 3, 4, 5 triangle, and that is a -4 being inside, because right now we are in the third quadrant and both x and y are negative. Now, what we're going to be looking at for the next 3 questions is I want to go ahead and find out where the sine of theta divided by 2 is, where the cosine of theta divided by 2 is, and where the tangent of theta divided by 2 is. Now, before I can do that, I have to find out where that angle is going to be. So what quadrant will theta divided by 2 be in? So what I have to do is I have to start with my given piece. Right now I'm taking, and I know that theta is in between pi and 3π/2. So what I have to do is I have to go through and say, take that interval and divide that interval in half. And the reason is I'm taking half of that angle. So I take that pi and that 3π/2, and I'm taking and I'm dividing all of those by 2. And whether I divide by 2, if I have a fraction, I multiply by 1/2, because this is what I'm looking for, right? All of those pieces, that sine of theta divided by 2, theta divided by 2 is always divided by 2. So this now, my new interval, what quadrant is that? My new interval for all of these is pi/2 and 3π/4. So where is that? So pi, my theta/2 is now all right, so I'm going to minimize this, keep this up here. Let's keep it over here for now, as we go through and work through what we're talking about. Now, let's find out what in the world the sine, after all of that we're doing. Let's go through and find where that sine piece and what is theta over 2 actually equal to? As we just said before, that sine is positive, so the formula that I'm going to use for this, I need my positive, the square root of 1 minus my cosine of theta over 2. So I just have the square root of 1 minus the cosine of theta over 2. So what is a cosine equal to? Cosine is equal to the adjacent over the hypotenuse, or the x over the hypotenuse. My x value here becomes 1 minus, that's 3 over 5, all divided by 2. So I turn that 1 into 5 over 5. So now I am left with 2 fifths divided by 2. All right, so let's go ahead and we're going to do the same thing, only now we're going to go ahead and do that for both the cosine of theta over 2 and the tangent of theta over 2. So I'm just going to go ahead and redraw my original triangle that I had, -3, -4, and 5 for my values as I'm going through and doing the cosine of theta over 2. But again, recall, because my original interval was pi was between theta and 3 pi over 2, and I want to take half of that angle. That angle ends up being between 3 pi over 4 and pi over 2. So the angle that I'm looking for here is in quadrant 2. It's up inside here in this region. So that means my cosine function, my cosine in this piece, is definitely going to be negative. So I want to go ahead and use the negative times the square root of 1 plus my cosine of theta all over 2. My cosine of theta is just the adjacent over the hypotenuse, or my x value, which is that 3, so that's where I get the 1 plus my -3/5. Yes, I have to put the negative there, and I have to keep the negative outside. I need both of them. I need this negative from the original angle, and this negative is from where the theta divided by 2, because that's in the second quadrant. I need to have both of them. So now I go through and do this. Out I get negative. On the inside I have 1 minus 3/5. Turn that 1 into 5 over 5. All of that is divided by 2. And if I finish this out, I will go ahead and get 2 over 5 divided by 2. Dividing by 2 is the same thing as multiplying times 2 over 1, in which case I get negative on the outside, the square root of 1/5, which is -1 over the square root of 5. I've rationalized that, and you go ahead and get the negative square root of 5 over 5. Yes, you must rationalize all of your fractions. All right, so the last one for this video, the tangent of theta over 2. I'm just going to use the fact that the tangent, I'm going to use the one that doesn't have the plus or minus in it. Makes our life a little bit easier, because then I can just say this is the sine of theta all over 1 plus the cosine of theta. I don't have to worry about that plus or minus, and I can use all of my original values that I had for there. So my sine of this is just negative 4 over 5, and then this is 1 plus the cosine, which was negative 3 over 5. So what I have now is just the fact that this is all equal to negative 4 over 5. I'm going to turn that 1 into 5 over 5 minus 3 over 5, negative 4 over 5, all over 2 over 5. Those 5s basically cancel each other out. The reason they do is basically what I'm saying here is I'm multiplying this numerator and denominator by 5 over 5, and those cancel. And we are now done, because now I am all left with that is just negative 4 over 2, so all of it just is equal to negative 2. And that is the last one for my half angle formula.